Hi, in this video, we want to take a look at price returns and we want to do the calculations in R. Okay, so I've got stock that I'm following, that I'm interested in, and I can see the values. Now, what I want to know are the price returns. I want to know proportionally from day to day, how is it doing? How is it going? So I want to take today's price, and in particular, we're going to look at closing price. Look at today's price, and I want to compare that with yesterday's price. So now, if if the difference is like rather large, but it's a huge stock, then that's not such a big deal. If it's very big, or maybe actually no, if it's a small change compared to other stocks, but it's a very small price stock, that can be a big deal. So it's not just the difference in the change, it's also proportionally, is it a big deal? So I want to calculate proportionally how big is the change compared to the previous day. Okay, so what we're going to do is we're going to take today's price minus yesterday's price. All right, so that gives me the difference between the 2 days, but then I'm going to divide by yesterday's price. That way I can get proportionally how big is the change. Now, this code is modified from Clifford Ang's book, Analyzing Financial Data and Implementing Financial Models Using R, and we can get it on Amazon or Springer. All right, so here is our formula. All right, so our price returns is today's price, or the day that we're interested in, the previous day's price, and then we divide by the previous day's price. Okay, now it doesn't have to be day, it could be week, it could be year, it could be month, it could be quarter, in the value that I want to choose for the time span. I'm just going to say day just because that's what the example I'm going to run through it has. All right, so now another way to write this is if I break up the fraction here, and then I notice that I've got this and that, and they're on top of each other. So I can rewrite this as today's price divided by yesterday's price minus 1. All right, so what this does is if there's no change, it's just 0. If there is positive change, then it's going to be a positive number. If it's negative change, it's going to be a negative number. All right, real natural, real easy. So 0 is our baseline for this calculation. All right, so now let's go ahead and load our data and take a look at what's going on. Here, this is just something I always do. I like to suppress the number of digits being presented in the presentation. Long decimal places distracts the reader, so I put digits just down to 2. And for scientific notation, what this does is prevents R from using scientific notation when like regular numbers would be easier to look at. Now, I'm going to go ahead and get some well-known stocks, Amazon, Alphabet, and 2 other major stocks. And I'm going to use batch get symbols to get my data. All right. And now, something about this, you'll notice that I'm taking the difference between consecutive days. If I want to have every day present in my analysis, then I need to have more days pulled than what I'm actually interested in. All right, so if I had 30 rows of data, then I would be able to get 29 differences between prices. All right, because I have to, when I look at today, I have to subtract off yesterday. All right, well, if I look at my very first data point, my very first observation, I don't have a yesterday to do a subtraction with, so I'll have a missing value. If I don't want to have a missing value, I have to get more data than I actually want for the analysis. And so here, I'm going to take a look at 30 days. I went ahead and pulled 60 days total, just because I just wanted like even numbers, just so it's easier to interpret when we look at it. All right, and now we get our feedback, letting us know that we got the data that we wanted with these 100% statements. And here's what the data actually looks like. We have open, high, low, close. We have the volume, price adjusted. We know the date. We know which ticker it is. And here is the relative adjusted prices and return adjusted prices, return closing prices. Okay, and this is the tail of the data. So the head is, the first rows, the tail are the last rows. So now let's go ahead and prepare the data for the analysis. Okay, so notice that I have 5 different tickers I'm pulling. Okay, so if I was to go through and just drop the data into the subtraction mode right away, what it would do, it would perform subtraction with like the last Amazon with the first Alphabet closing prices. Well, if you think about that, that doesn't make sense. So to be able to do this, I need to break up my data by the tickers. Otherwise, I'm going to start combining things in ways that don't make sense. So what I'm going to do, I'm going to use a split function. I'm going to take the data. Oh, something I need to say. On this step right here, I'm reducing the data only to the columns I'm going to be using in my analysis. That way you just have like cleaner workspace. It's and also when you have like a big data project, if you reduce it down to just what you're using, you'll have, it'll take less time to do your computations. So here, I'm splitting the data. Here is my data set. And here I'm saying split it by ticker. F stands for factor that we're splitting over. And so now, once I have that, I need to go to each subset of data. So inside the list underscore M, I have a subset of data. I have the first ticker data set, I have the second ticker data set, third ticker data set, and so on. Okay, so now I'm going to go over each of those sub data sets, and then I'm going to compute the price return. Now in quant mod in R, the function for doing this is delt. All right, so delt for delta change, the difference between the two. And we're going to do the arithmetic one, just straight subtraction instead of logarithm division. All right, so here, all I do is I take quant mod delt, I pass the data that I'm interested in, and notice now this part, I'm indicating I want to work on the subset of data that is contained in my list of subsets on this step right here. And then I just store that in the subset. Okay, now on the next step, what I'm going to do, I'm going to go through, I'm going to get rid of the observations I don't actually want. So remember, for my goal for this analysis, I'm only interested in the last 30 days. And by pulled in the past 60 days, I have more data than I need. So I'm going to go through and I'm going to do a logical statement. So I only go back 30 days. I take all the dates that are greater than or equal to, the system date minus 30. And then I just reduce down the data sets in each subset this way. Now I have each subset of data. I have the price returns, and I've gotten rid of rows of observations I don't actually want in my analysis. Now let's go ahead and take everything and put it all together. And to do that, I'm going to use Dpr Bind Rows. This is a really quick and easy way to take data that's split over a list and stack them on top of each other and very quickly get the results you want. Oh, there's something I need to say, something I forgot to mention. You'll notice I put as vector in my delt statement. The reason for that is because the delt function by default gives us a matrix. All right, well, for this purpose, for this output, it's a matrix of one column. So I just convert it to a vector. That way it agrees better with being attached onto a data set, a data frame. And now for my visualization, when I go on to ggplot, I need to have things in a tidy format. So what I'm going to do, I'm going to take, if this is my closing price, and this is my price return, what I want it like this. I want it in a long format. So I'm going to use the gather function from the tidyr package. All right, so what this is saying is take price close and return close and convert them into one column. So I have a bunch of columns. Now I'm going to have fewer columns, but I'm gaining more rows on my data set. Now when I do this, I need to specify the close, and so I have to create a key column and a value column. All right, so it's always it's it's either a closing price or a return on the closing price. So I just call it the key to close. If you don't know what to do on this step right here, call it key. And if you don't know what to do on this one, just call it value. Here I said price, just to call it that. Now let's actually visualize the results. So I'm going to use ggplot, and we're going to have the x-axis is the date, the price, so that's either the return price or the closing price is the vertical axis. The color goes by the stock, and I'm going to use faucet grid so that I have closing price and then price return, and then we go horizontally by ticker. Now here I put the legend up top because I felt like that was a little bit more organized for this particular plot. And then to make it so that the x-axis is not so crowded, I rotated the x-axis 45 degrees. And now I have the results. So here I've got time series plots. Now something about the top, if I look at the closing price, here NVR is so much bigger than the others that it really kind of squashes out the closing price of the others. It's hard to see the details. We have, vertically there and horizontal. Vertically, we see a lot of space between the lines and the actual plots themselves. So here, if I wanted to go back into this, I might either consider a logarithm or I might want to break up the individual plots. But this is a good approach as a first look. And now I can look at the price returns for Amazon, for Alphabet, NVR, and SEB. All right, well, that's all I've got for you. Take care and goodbye.